Good morning, everybody. Thank you very much for coming along today's webinar, which is part 3 of Machine Safety and Plant series with Brent Sutton. I know it's a busy time of the year, especially for the retail supply chain. So we do appreciate you coming along today and making the time. It's been a pretty interesting series so far, and I'm pretty sure it's just going to keep on with that whole same interesting level. There's a couple of parts still to come, so please make sure that you do register for those. If you have missed maybe part 1 or part 2, it's okay. Just go over to our YouTube channel for ShopCare and you'll find both parts there. We'll have part 3 also online on our YouTube channel, hopefully maybe towards the end of this week, if not by early next week. And then please don't forget to come along to our last webinar for this year, and which is on 20th December with Brent and with Shirley, also from ShopCare. But without further ado, guys, make sure you use the chat function. I'll monitor the chat function, so if you've got any suggestions, any comments for Brent or for myself, I'll monitor those and pass it on. Make use of the questions and answer function as well if you have got any questions, and towards the end, if there's any time available, we can open up the lines and you can ask some live questions to Brent. Okay, guys, before I do anything else, I just want to say thanks to Brent for coming along today and sharing your expertise again with us today. And I'll be in the background, guys. I'll see you in about 25 minutes or so.
That's great. Thanks, Wes. And thanks for everyone sort of coming back into it. I really appreciate that. And today, it's going to get a little bit more interesting today, because we're going to be exploring in the session about how we reduce machine risk using the joint New Zealand and Australian standards called 4024. And I think from my perspective, there is this trend at the moment that we're seeing from WorkSafe, where they are quite critical about the risk assessment or the competency of the person that was assessing that machine. And that's why this module is actually really important, because one, it allows us to explore what is the actual risk assessment standard for machinery. We're also going to look at the difference between acute harm versus chronic harm with machinery. And then we're going to wrap up by exploring how do we reduce risks? So what is that risk reduction process that we apply to machinery? There we go. Let's start off with a copy of the standard. So isn't it wonderful? 4024.1303. What's really interesting is that this part of the standard is there to provide you practical guidance and examples of different methods on how to manage machinery risk. Like all good standards, it is not dictating that you must use a particular model. So in actual fact, you can even use your existing model now. So if as an organization, you're quite partial to a 5x5, you can still use it. But what the risk management standard is trying to do, it's trying to get us to explore what are some of the risk factors that we need to consider before we then evaluate and assess risk in that way. So the standards aren't focusing on a model. The standards are focusing around the risk factors. So let's explore that. And just to make sure that we've got some connection with machinery, there is still that frequent word of the use of a hazard. That sort of lost a little bit of favor when we redid the Health and Safety at Work Act, but in machinery risk, it's still very present. And just a reminder, a hazard is something that can injure you, make you sick, or kill you. In other words, it is the source of the harm or the loss. Risk is the chance that being exposed to that hazard can or will lead to harm. So the chance of it going wrong. And risk management is the process that we're going to be following to control those risks, whilst ensuring that those controls, that we monitor them to ensure that they remain effective over time. So machinery risk wants us to explore that notion of harm, and it wants to explore it in two ways. One is around the physical, the safety risks around that machine, and they're very much physically based. And it also wants to explore the health risks, and we call that the chronic harm. So the physical risks are about acute harm, and the health risks are around chronic harm. And machinery safety also incorporates the psychosocial component of that. And that psychosocial component can actually sit in both camps. So this is a diagram that is directly from the standard. And this is where I think it gets really interesting, because if we look at the very bottom of the diagram, what they're saying is that on that machine, you need to evaluate both the harm that can happen from the acute process, so that's the physical harm, the injury, and you also need to evaluate the harm to health, that's the chronic process. And each of how you would determine those risks will be different, although the hazard, the source of the risk, may be the same. And in that process, it's wanting us to explore that when it comes to physical harm, that acute process, it wants you in your risk management process to understand the relationship between the person and the hazard. And it describes that relationship as the hazardous situation. So for instance, if I look at a machine, there might be a hazard on that machine, and say, for instance, it is a moving part on that machine. And that moving part could eject material, say, for instance, like a conveyor. So that conveyor might be transporting, I don't know, large, heavy items like rock or concrete. And what the standard is doing is it wants you to explore, based on the types of tasks and activities that workers do when working on that machine, it wants you to understand and explore when are those hazardous situations present. Remembering that that situation may differ depending on the machine is being set up. It may differ when there's some form of alignment being done on the machine. It may differ when we're actually running the machine. And it also may differ when we are clearing jams or cleaning the machine. And it's asking you to explore those different modes of how people operate on that machine. And just because it's a hazard situation doesn't necessarily mean that it's going to lead to an event. But it's the situation is the part that we want to explore around managing that risk. On the health side, it's basically saying we're going to swap out the hazard situation and we're now going to replace that with exposure. So on the health side, it's basically saying it's the presence of the person to the hazard, it is exposure to that hazard, and it is the length of time that they're exposed to that hazard that then leads to harm to health. So for example, we think a lot about the health risks of machines around things like noise. And there's already very good guidance around noise levels and how we can do that. So that's pretty straightforward. Another issue could be around lighting. So the lighting around that machine becomes really important because there are different levels of lighting depending on the task the person does. So if the person is having to sort a product on a machine like a conveyor, then that lighting level needs to be sufficient so that they can sort. But just imagine if that person's job on that machine is some form of inspection, where they need to be able to get closer into more detail. Therefore, that lighting would have to be different. And of course, there is a risk of poor light, not enough light, and there's also a risk with too much light. The other classic examples might be materials or substances that form part of that machine. So there are many different types of hazardous substances that form part of that machine, whether that be hydraulics or pneumatics or solvents. So it's about the use of those products in that machine process. And another good example, one that's not talked about very often, is around vibration. So the design of that machine may mean that there's some sort of vibration that the worker is exposed to. And of course, a big risk factor around vibration is how often that person is exposed to, because the impact of that vibration could be on their musculoskeletal components of that. So you can see there that whilst we're focusing on the left side around the physical elements and the classic ones there, being able to be struck by a machine, crushed by a machine, puncturing, entanglement, all those classic sort of physical acute harms. On the right side, we're focusing on the health side. And when we think about that, by understanding that relationship between the hazard and the person, remembering that's a two-way relationship. So if I think about, fixed plant, the person's having to go to the hazard. If I think about noise is traveling to the person. If I think about mobile plant is coming towards the person. So it's also asking you to explore those relationships. And that difference between the event-based type harm versus time-based harm is always fascinating, because this is where the human behavior comes in. Because when we think about event harm, it becomes obvious about the event because there is a sense of danger. The problem when we think about time-based is we don't perceive time. So we don't perceive length of time or proximity to the hazard as being danger. So the example could be where I'm presenting today. I'm fairly close to the zoo, Auckland Zoo. But of course, we know there are hazards at the zoo that could kill us, for instance, tigers or lions. But because of that distance away from the zoo, I'm not really perceiving any danger in doing that versus a tiger being outside my door. So as humans, we can relate to events, but we struggle to relate to time. So what the standard is trying to do is the standard is trying to explore the context of time and the context of the event by looking at the relationship. So when we think about the acute process, that relationship between the person and hazard can lead to a situation. That situation can lead to a potential event. That event then can lead to the injury itself. Same thing for that chronic process, the exposure to that hazard. When the person is working on that machine, it's the length of exposure or the frequency of exposure that then leads to harm to health. The standard then says that once you understand that relationship, then you can move into the risk reduction side of it. And when we think about risk reduction, what they're trying to explore is in this diagram here. Now, I don't know what you guys think of it, but it looks fairly complex. So let me take that diagram or that flow chart from the standard and let me present it in a different way that may help you around understanding a little bit better. So let's change that over. And let's now take this from this design. So what are we experiencing here? What we're saying is that we reduce risk over a hierarchy of reduction methods, starting from initial design to designing out to protective measures, safety controls, information, followed by training, organization, and safe systems of work. And it's no different to the hierarchy of controls. what they're basically saying is that whatever we can't design out is always going to not be as good as applying other levels of controls. So when we think about hierarchy controls, obviously it's eliminate first, followed by substitution. And as we move further down that list, what it's saying here, it's its ability for those controls to be effective reduces over time. So let's explore what some of those things mean. So let's start with initial design. And this is where it's been important, because what they're saying is that whatever you can do at the beginning, whatever you can do at that procurement phase when you're designing that machine, that has a huge influence throughout the life cycle of the machine. And whatever you can't achieve in the initial design, you then have to do that by designing out the hazards. So when I think about designing out the hazards, what they're sharing with us is that we need to think about designing those hazards out using this hierarchy, that we need to design out the hazards by focusing on the severity of harm. And if we can't design out based on severity of harm, then we need to design out based on exposure to the hazard. And then lastly, on the occurrence of it. So let's explore what some of those examples could be. Sorry about that. So, severity of harm. For instance, we could reduce energy as an example. So we could lower the speed of something, we could lower the force, we could lower the pressure, we could reduce the height. So for example, with mobile plant, reducing the speed from say 10 kilometers per hour to 5 kilometers per hour has a huge effect about the risk of a worker being struck. The first effect is that 5 kilometers per hour is the equivalent of walking speed. So reducing speed down to 5 gives a person the greater ability to respond if they were come into the working zone of a machine, or if a machine was to come into their working zone. Secondly, if that person was struck at 5 Ks, that severity of harm is going to be much less than if that machine struck them at 10 kilometers per hour. So it's the same thing. If we can lower pressure, if we can lower force, if we can reduce speed, all those things has a great impact on the severity of harm. If we can't address that risk by focusing on severity of harm, then we need to focus on where we're going to the greatest effect is going to be on exposure to the hazard. So what do I mean by that? It's not just about how much time a person spends. It could also be how many people. So by reducing the number of people also has an effect. So for instance, at the moment, with shortages around workers, there's a lot of automation that's going on. So automation is a classic example of reducing that risk through exposure to the hazard. Or we could relocate the source of the harm. So noise is a classic one. We typically default with hearing protection. But in actual fact, we should start by trying to eliminate that noise. For instance, if there is an air compressor that is feeding the pneumatics of that machine, why can't we move that air compressor outside the work zone or outside the building and have the lines coming into that machine? Or why can't we put some form of shroud or sound deadening around that compressor as well? So there's lots of different things we can do around exposure to harm. And then the last one there, sorry, my apologies, is around the occurrence of the event itself. And that is where we can improve the reliability of machinery. So replacing old machinery with new safety features is an example. Or where we can put in redundancies around certain controls. So for instance, if we think about hydraulics is a good example. If the hydraulic line was to fail, what prevents that ram from falling? So having a non-return valve, for instance, means that if the line fails, we've built redundancy in that ram won't fall as a result. So with machinery, we need to think about those three components: severity of harm, exposure to the hazard, and the occurrence of the event occurring. If we can't design out, then that is where we explore protective measures. So what's a protective measure? Well, this is where we start to explore what are called safeguards. And there are two types of safeguards. Safeguards that focus on exposure to the hazard. So some classic examples are fences, barriers, and different types of guards. So with guards, we've got fixed guards, we've got guards that, for instance, are removable, we've got self-closing guards, we've got moving guards, and we've got guards with interlocks. And in our next session, we'll be exploring around that hierarchy of guarding. But I think what's interesting is that the regulator always defaults to guarding as the first port of call, but in actual fact, if we go back to what the machinery safety standards are saying, it's actually third in line. And then there are safeguards that then focus on the occurrence of the event itself. And that's your light curtains. That's those sensitive mats, other types of sensing devices, hold to run devices, or things that limit movement or limit devices such as pressure, temperature, or overspeed. So if we think about that, what it's saying is the best bang for buck is to keep people away from the hazard. If you can't keep them away, then your next thing you're doing is you're then focusing on the occurrence of the event happening itself. And if you can't apply safeguards, then that's when you move into safety controls. And safety controls, they're very much that complementary component. And there's two types of safety controls. Ones that look to avoid or limit the amount of harm. So an example, an emergency stop is a classic one. An event or a situation has occurred, and the emergency stop is the last line of defense for that worker to initiate a stop. There's no guarantee that that emergency stop will avoid that harm, but part two of that emergency stop is to limit the amount of harm. Because remembering that an emergency stop, it might take time for that hazard, for that energy of that hazard to reduce. Another good example of a safety control is around safe access to a machine. So I'm dealing with a recent case around a piece of equipment in the horticultural sector. And this piece of equipment removes the skin off a type of produce, and those skins go into a hopper. And there was a panel on the hopper that could be opened to basically clean the skins out or to clear jams. The problem was there was no padlock or there was no control on that door, and that door could be opened and a worker was able to reach into that and reach up into the moving parts. Now, did the worker knowingly do that? The answer is they did not. They believed they were clearing a jam. They didn't believe that they were getting their hand that close to the moving part. The second component around safety controls are ones that reduce exposure. So that's things like your energy isolation, your valves, your switches, or your mechanical blocks. So a classic one, you might have a machine that uses hydraulics or pneumatics, and in that cleaning process, you actually want to put blocks in that holds that part of the machine open, not relying on the lines of pressure keeping it open at that time. So that's why we call them safety controls. And normally safety controls are complementary to something else rather than being there by themselves. The next component is around information. And I think there's two parts to this that I find fascinating. The first part is actually around signage. And under the machinery safety standard, it basically says that hazards on the machine need to be identified by pictograms or symbols. And on here, I'm just showing you some of the symbols that you may not see that frequently, because the most common symbol that would use, like a yellow triangle with a lightning bolt, is the most common symbol of live power that you'll see on power control boxes or on control switches themselves. But I found here some very obscure symbols. So this is a great time for me to test some people's knowledge. The symbol top row, third in from the left, with a little picture of a man. What do you think that symbol is depicting? What are people's thoughts? You know, either chuck it into the Q&A or the chat box. Slip, trips, and falls. Yep, we're getting close. So for instance, that could be where there is a risk of fall whilst working around that machine. So a good example could be, basically you might have a working platform around a machine, and people in the cleaning process need to open up a part of that machine. And that's where a fall risk could exist, because basically they now don't have that space around that machine. So the one I talked about earlier in the bottom left-hand corner, that's a classic one where there could be a mechanical part of the machine that can fall. So that's actually a bit of a crush type hazard. And the obscure one in the bottom right-hand corner is basically one around the release of gas or the release of pressure. And the one to the left of it is one where you might have fragments that can exit the machine. So every machine should have these symbols on it. I got to tell you, I don't see them very often. But the whole idea, the reason they're supposed to be there is they're supposed to inform people about the presence of a hazard. What I see lots of is lots of SOPs, or I see lots of work instructions. The problem here is, how often do people actually look to those work instructions? So the whole idea about risk reduction through information will never be as effective as those other hierarchies, but we need to make sure the person is aware of that. The other big no-no that I see is I see machinery with foreign languages or labels in foreign languages. They shouldn't have that. The machine should have a pictogram where possible, and if we're needing to use English, labels, it needs to be in English. So, you know, if you've got a machine in from Japan, for instance, there shouldn't be any Japanese. I recently saw a machine that was all in Spanish. I just don't understand. You know, it should have, all labels should be in English. And then the last component of that is around training and safe systems of work. And I don't know how you feel, but really the effectiveness of training and safe systems of work is never as good as those higher order controls. And really what we're trying to do is we're trying to really mop up that residual risk that sits between all the other controls around designing out protector of safety controls. And we're really trying to mop up that difference between the residual risk and the normal work that is being done. Are they going to be effective? I don't know, because it requires much higher levels of monitoring or supervision or some sort of feedback around making sure those things still work. So, you know, one piece of advice to people, even putting in a brand new machine, is that always go back within 90 days to see how the use of that machine has changed over time. Because humans, by their very nature, want to be effective and efficient, and they will find different ways of changing that. So that standard is available on the standards website. Personally, I use that standard for lots of other safety components because it really gives us some good insights. And in particular, that standard explores the difference that we don't see in a traditional risk model, because it's asking us to think about estimating that risk by understanding, you know, the exposure of persons to that hazard, the probability of the occurrence of that event occurring. And it's also asking us to explore not only the technical limitations, but the human possibilities to avoid. So the classic one, what I think of, is what's called the line of fire. So if we've got people working on a machine and they are in the line of fire where that machine can release energy, relying on people to understand that and work with it every day is always going to be the weakness. So how do we shift people from that line of fire? So a classic example I encountered was a machine that was using ultraviolet radiation as part of a curing process. And they used to have workers in that zone, and they would inspect the material as it came out of that UV bay, that drying bay. Of course, that means that there's radiation being released into that zone. And their initial response was, right, get them to wear, you know, sunscreen, or get them to wear a UV shield. Where in actual fact, the simple solution was to put a camera into that zone and have a monitor outside the zone where the person could do the inspection. That delivered the best bang for the buck, because I don't know what is a safe level of radiation. And the problem is with things like skin cancers in particular, it's about not only, you know, that one event, but it's also that continuous exposure to UV over time is the big issue, which is what we're seeing with things like welding now. Okay, so question time. So this is where we might get back and we can get people's cameras or microphones open if they want to ask any questions. Remembering in our next module, we're going to be exploring and identifying the different types of physical machine hazards. So any questions or observations from people around that?
Nothing from my end, mate. It's been an interesting one. It's very good as usual.
Yeah, risk ID doesn't have to be that hard. The wonderful thing is that, with machineries, finding the hazards is actually the easier part. I think having conversation with the workers around the work that they do, that's the bit that takes more effort. And that's the bit that I see in particular is really something that as safety practitioners, we can really step up and do, because it's something that engineers don't do very well. So I think, the ability to have a conversation with workers about how they do the work, that really helps us to manage that risk better.
Any other questions for Brent, guys?
Everyone's a bit quiet today.
Yeah, pretty quiet today. Okay, well, we are over our normal time limit. It's been a good one. If there is no other questions coming in currently, shoot them off to Brent or myself if you've got any others or any other suggestions as well. Guys, if I don't get to speak to you again, this is my last one for the year. Like I said earlier on, next time it will be with Brent and Shirley. But yeah, I'm pretty sure majority of you will all be there. Like I said, this webinar will also be uploaded to our YouTube channel within a couple of days, so watch out for that if you want to have a re-go at this one. I just want to say thank you again to Brent for taking the time today, mate. I know you put a lot of effort into this. It does take up some time, and I also want to thank everybody for coming along. And like I said a little earlier on, it is a busy time of the year, but we do appreciate you coming along. Other than that, guys, have a good one. I hope you enjoy your I'm not going to see you guys. Hope you have a good time. Enjoy your time with your family, and have a good rest. Until I see you again, remember the next webinar is with Brent on the 20th. See you guys. Have a good one.
See you guys on the 20th.